Hello. Today is topic 2, section 2, functions. So any set of ordered pairs, don't know why I put pair. Okay, any set of ordered pairs is called a relationship. Okay, so just a bunch of x and y's. Okay, a function is a specific type of relationship. Okay, think of a relationship as being a quadrilateral and a function being a square. Okay, a function is a relationship, but not all relationships are functions. Okay, functions are rules. All right, you deal with numbers, they have to pass the vertical line test. And this is function notation. So I usually say f of x is a fancy way of saying y. All right, because when you talk about functions, usually it's real world problems. So you talk about input and output. So if I have this, what will I get? And so x would be what you're putting in, and f of x is what you're getting out. Okay, so the y would be the output. Okay, it can also be written this way as x, every element in x is unique set to y, meaning that the x's don't repeat. That's what the vertical line test is. The x's don't repeat. So a lot of times you'll see relationships organized as a mapping diagram, which is what this is. So here you can think of the left side as being your input and the right side being your output. Okay, so we're thinking x's and y's. Another way of thinking about them is your domain and range. So notice that's all alphabetical, in case you ever forget. Okay, all alphabetical. So x then y, I then o, d then r. Okay. So let's see. If you want to, just so you understand what the mapping diagram is this is how they organize their points through these lines. So you follow the direction. So we input 1 and we get out 6. So that point would be 1, 6. Then the next line, 2, 7. Then the next one, 3, 7, 3, 8, and 4, 6. So now that we've listed out our ordered pairs, maybe that's a lot easier to see that this is not a function because of our x's. So this is not a function. So it says, if it is, write the domain and range, explain your reasoning. So we're going to say, no, it's not a function. Ooh, don't really know what I was putting there. Okay, function. All right, because the x's repeat. All right, the second one, it's asking, is it a function? Now here we don't have to list all the ordered pairs because we can see when it repeats or not, because look how the 3 had 2 lines coming out of it. That was the problem. The 3 was being repeated. Here, every line is coming out of a different number in the domain. So yes, it's a function. All right, because every x value is unique. Okay. All x's are unique. That's my reasoning why. So to list the domain, we use braces, or braces, I don't really know the plural of it, but at the little squiggle lines, okay? And we list the numbers. Typically we list them in order from least to greatest, but I don't really care personally. But standardized testing is going to. And here the range is 2, 4, and 6. I can tell you the biggest issue I have with when kids list the domain and range is that if they do repeat, kids repeat them here. No, do not tell me 2 twice. Okay? Here you're just listing what the numbers are. You're not listing how many. You're not giving me counts. You're not giving me all of them. You're just giving me the one-time hit of them. Okay? All right, so let's keep going. All right, determine whether the following relationship is a function. So, is it a function? No, not a function. X is repeat. It's terrible X. There you go. Got to work on my handwriting. So let's see. Determine whether a relationship is a function. Okay. So here, our issue is whether or not the x's repeat. Well, let's figure out what x is. Let's isolate the variable x. So what I mean by that is we do x squared equals 25 minus y squared. And then we take the square root. So we get the square root of 25 minus y squared. Now, hopefully you remember, if I take the square root, I have to put plus or minus. Okay, I said that all through Algebra 2. Okay, you put the square root there, you put plus or minus. Okay, so then notice what happens. Okay, I've got two values. Okay, so that means that if I have one x value, all right, that gives me two values over here, plus or negative. So x can either have this, and also I'd have to solve for negative 25 minus y squared. Okay, so since there's two x's, so it can't be a function. Okay, that's how we can tell. Okay, so domain and range notation. So let's see, you probably started off in Algebra 1 with just your inequality notation. Okay, just writing it this way. Remember, if you have it equal to, that's when you have a closed circle. When you don't have it equal to, that's an open circle. So that means that it's just the numbers getting close to 4, but not actually touching it. Kind of like an electric fence, okay? X can be 4.1. It can be 4.01. It can be 4.000000001, as long as it's not 4, right? So that's what the open circle means, okay? It's a boundary, okay? Now, set notation, that's the super fancy textbook way of writing everything, okay? This is at the end of your questions and in your assignments, and this is what throws you guys off, okay, right? X is an element of a real number. Okay, so X has to be a real number, okay, so nothing imaginary, and it has to be between 4 and 9, right? That's what this is saying, okay? Yeah, I think it just cut off there, and the squiggly line is supposed to be at the end down here, okay? But you get the idea. Let's see, interval notation. This is what I prefer. Okay, so now I'm seeing how they're doing it. Okay, I'm used to the parentheses. Okay, parentheses mean an open circle, and then the bracket means a closed. All right, these backwards parentheses means that it's also open. Okay, so if you want to write it that way, that's fine, but to me, that's, I don't know, wonky. I don't know. I like the parentheses for an open circle and the bracket for the closed. But again, either one for interval notation, I'll accept. Okay, so you just want to get familiar with writing it this way. Okay, you want to know and understand the different notations. Don't get too caught up on the notation though. Okay, so let's do the domain and range. So let's start with the domain, and I don't want to write in yellow, so we'll just do that one in, I don't know, green. Okay, so here's the domain. It's along our x-axis. That's what we're looking at, what x can be. So the blue line is our function, all right, and we know that that's going to keep going on forever, all right, x squared plus 1. So here, we know that if it's going to keep going out to the left, that it's going to keep going on and on towards negative infinity. And on the right side, it keeps going to the right, so it's going towards positive infinity. So I would write the domain from negative infinity to infinity. And we put parentheses around infinity because you can't actually touch infinity. I will never get to the point and be like, whew, I'm done. I finally made it to infinity. All right, it's not going to happen. So use parentheses with infinity. Now for the range, all right, I can do that in pink. So here we're going to look along the y-axis. Now we don't go down forever, right? There's a cutoff point. Our function's not going to go below here. So it's going from 1 and it keeps going up. Okay, since my parabola keeps going up, my range is going to go from 1 to positive infinity. Parentheses there. Now since it's actually at 1, I'm going to put a bracket there. Okay, domain is much better. Okay, not domain. Interval notation to me is just so much easier than writing it as an inequality. Okay, so most of you are pretty comfortable with that. I want you guys to understand this. So let's see. If you did write it in inequality notation, this would be well, you would just say all real numbers. Okay, so x is an element of the real numbers. Here, let's see. Then for the range, you would say x has to be greater than 1. Oh, greater than or equal to 1. Of course, it's the range. Silly me. So it's a y. Okay. So let's do the bottom one down here. So here we're going to look at our domain, so going left and right. Since we're graphing this line, we'll notice it's not going to the edge of my graph. Okay, it didn't go to the edge, so it's stopping there. This one's stopping there. So my domain is only going from -1 to 2. So I would write it from -1 to 2. But again, you can write that as -1 less than or equal to x less than or equal to 2. And then for your range, the lowest part is -2. You're looking at the lowest part and the highest part. So the range is from -2 to 4. So we can also write that, getting ahead of myself, like this. Okay, again, I have a lot of people that mess these up, so let's practice some more. So you want to think about these. Our domain for the first one is going to be from 0 to infinity. Notice it's going to the edge of my graph. So 0 to infinity. And the range is going to go from 0 to infinity as well. Okay, because that's what it looks like. We're basing it off what we see happening. And now for this one. Okay, so for this one, the domain is going to be, well, here you know it's going towards negative infinity. And here you know it's going towards infinity. However, there's a break in the middle. Notice that this one is getting very close to 1, all right? And this one is getting very close to 1. All right, there's something to be noted here, that this right here at 1, at x equals 1 to be more specific, there is an asymptote. Okay, so that's like a fence. It's going to, your graph is not going to touch it, but it's going to get very, very close to it. So here, it's going to go from negative infinity to 1. But again, not actually touch 1. And then it's going to hop. So use the union button, the union sign. And then you go from the other side of 1 towards infinity. Okay, that's one way. All right, that's interval notation. Okay, and what I meant earlier by you don't want to worry too much about notation just because there's so many different ways. I always take the easy way, honestly. So here, we basically did every number but 1. So an easier way of writing that is just saying x can't be 1. It's the same thing. I'll take it. Okay? If you want to put it in interval notation, go for it. If you want to just tell me this black part right here, x doesn't equal 1, that's perfect. Okay? Both are perfect. So let's do the range. So the range in interval notation is going to have a similar option or similar problem. There's an asymptote at 0. So you're going to go from negative infinity to 0, then 0 to infinity. Or you can simply say y doesn't equal 0. Okay? So when it comes to finding the domain and range of a function without the graph, all right, this is when knowing, I can't find my words, understanding how the relationship between functions, between the properties, okay, knowing that stuff is really what's going to help you here. So for instance, our domain is our x's. So think about it. What can I put in for x? Okay, can I just plug in anything I want? Okay, well, no, I can't plug in anything I want because some values aren't going to work, right? Because I should know that the square root of a number, all right, that square root is going to give me a positive number. Okay, because I want to do the square root of something real. I can't graph anything imaginary. So I need to, this value has to be bigger than 0. So x plus 2 has to be greater than or equal to 0. Yes, we can put the square root, but the first option is, or first thing you do to get rid of it is square it, right? So really just everything underneath the radical needs to be positive. So x must be greater than or equal to negative 2. That's your domain. All right, then our range is, well, think about it. It's our y's. So I know that the smallest thing I can do for x is negative 2, right? That's the smallest number. Well, if I plug in negative 2, that means this is going to be the square root of 0. Well, yeah, I can't take the square root of anything smaller than 0. So my output has to be bigger, right? So again, the square root of a number must be bigger than 0. So that's all I have, is that y must be bigger than 0. Okay? So again, interval notation or set notation would be perfectly fine. So this is from negative 2 to infinity, and this is from 0 to infinity. All right, so here is another equation. So here we have a fraction. Okay, well, what can go wrong with fractions? Well, a big no-no is I can't have a number divided by 0, right? That's a big no. So that means x squared minus 1 can't equal 0. The denominator can't be 0. Okay, so that means x squared can't equal 1, which means x can equal plus or minus 1. Okay, other than that, I can divide any number by any other number. So my domain is x cannot equal 1 or negative 1, or plus or minus 1. Either way, I'll take it. Now for the range. This one gets a little trickier. I would get out your calculator and graph it. So when you plot it, you go to y equals, okay, in case you weren't there, go to y equals. This will pop up. You do x divided by, I'll do parentheses. I want to get all of x squared minus 1. So x squared minus 1. Make sure you put parentheses, because if you don't, it's not going to include that minus 1 underneath in the denominator. Right? It's going to put it outside. So then, let's see, I'm going to do my zoom standard, number 6, and that kind of just resets my graph from negative 10 to 10, and then negative 10 to 10, excuse me, for both the domain and the range. So let's see, as you can see here, all right, I was thinking that it would be like this, the graph that I showed you earlier, because it had a fraction, but remember, graphs do wonky things. So it helps to graph it. Domain is a lot easier to figure out than the range. So I would always use the graphing calculator for the range. So here, our graphing calculator confirms that our range is going to be all reals. Okay, you can either write that, you can write interval notation, okay, or you can literally say all real numbers. Okay, so then I confirmed with calculator. That's how I can show my work. And I'll do a quick graph of it. So again, this is just showing that I did it. Okay, didn't have to be perfect, just doing a quick sketch of what happened in my graph, right? It's not perfect, but then that shows Miss Gross that I used my calculator, okay? Okay, so let's do the domain and range of this function. All right, so let's start with the domain. Well, we have a fraction, okay, and we have a radical. Well, we already know that the x squared minus 4 must be a positive number, right? It must be greater than or equal to 0. However, because it's a fraction, I can't have it be 0, right? I cannot do 1 over 0. So I need to eliminate this. So it needs to say greater than 0. So we're going to write x squared is greater than 4. So here it gets a little tricky. So this is when you start having issues with that plus or minus 2, right? We took the square root, but then we have greater than 2, but then also greater than negative 2, right? There's issues. So I like to think of it as a number line. Again, this is how you can do it algebraically. I'll show you the quick way. So you have negative 2 and 2. So you know it can't be those, right? Because it can't actually equal 0. What I do then is I can always just plug in values and see if it works. So if I plug in 0, do I get something that works? Well, 1 over the square root of negative 4 is not something nice. So x equaling 0 doesn't work. Okay. However, when y equals, not y, I just wanted to use a different variable, I guess. All right, when I do x equals negative 3, so that's left-hand side, all right, I get 1 over the square root of 9 minus 4. Well, that's a number that works. I mean, it's not a pretty number, but it's something I can graph. So this is something I can shade. Then I think the number 3, I plug that one in. Sorry, kind of get a different color. So when x is 3, we have 1 over the square root of, again, 9 minus 4, which is something nice. Again, not a pretty number, but a number that still works. Or at least it's real. And we get here. So now we get x is less than -2, while also x is greater than 2. Okay, we can also do that with our calculator. Whoa, what just happened? So we go to our calculator, we hit y equals, we plot our equation. I just like parentheses to make sure everything that I typed got put as the denominator. And then I hit graph. And then here it might be a little bit hard to see what's going on in this middle, so I'm going to zoom in. So zoom in, and it's already at the origin, so I'm just going to zoom in on that center. Okay, so maybe it zoomed in a little much, but I can always adjust my window. And I really just wanted to see that y value. So I'm going to change my y maximum. Sorry. So I'm going to try and change the height to be, I don't know, 20. Okay, so here we're starting to see that it's going up, but what are these? Oh, that's from my stat plot. Sorry, ignore those. Those shouldn't be on your graph. Mine's something else I did in my stats class. So it might be a little bit hard to tell, but this is supposed to be an asymptote. Okay, so sometimes our calculator doesn't quite show us exactly what we need to see, so maybe we need to adjust our windows. Okay, so maybe going to 20 was too high, and I wasn't able to see the line go all the way up. Okay, and see, you can start to see. Okay, it should go up forever. All right, so like, let's see. This one is like 2.0. Oh, I thought I was tracing it. Hit trace. So I'm going to hit, why isn't it letting me trace it? Oh, because I was on my plot. Okay, now I'm on my line. So let's do like 2.1. Okay, so that's there. So let's get a little closer to 2.01. Okay, now we're getting a little higher. What about 2.001? I'm way off my graph because look at my y value. It's 15.8, but you can't see it. Okay, that line keeps going up. It's an asymptote. All right, just to let you know with that. Okay, but here we can see that gap from -2 to 2. Okay, so again, we can just trace or graph it with y equals, then hit zoom standard. It's use standard graph, and if you ever want to adjust the window, you change it with this button. So here we can see x has a break, or the domain has a break in the middle. Now the range, we know it's going to keep going on forever because I can trace it. So if I start over here at like -9, why is it? Oh, because I keep going on my stupid plot. Okay, so if I trace at -9, okay, I'm at 0.11. Okay, and if I keep going along, I'm getting a little further, but if I go to the right, the left, I'm getting closer and closer to 0. That's my asymptote, so it's not going to hit 0. So my range is going to be from, oh, I guess I should have written it up here. Well, that's my domain, and my range is, what did I say? Everything is greater, y is greater than or equal to 0. Well, not equal to 0, sorry. Because a fraction, all by itself, should never equal 0, unless you had a variable on top, and we don't here. All right, let's keep going. Okay, so if we want to do it by hand, go for it. I say let's use the calculator. Okay, so I'm going to go ahead and turn off my stat plot because that's going to drive me crazy. So let's see, y equals, I'm going to clear that out. I'm going to put -4x squared minus 2x plus 1. So we graph it. and we should, there we go, get a parabola. Okay, and so now we can trace it. And here we're at 0, 1. If we go to the left, we're getting a little bit higher. Okay, but we need to know the highest point, right? So we can do our range. Oh, I guess, okay, let me start with our domain. Domain, you know, it's going to keep going left and right forever. So the domain is going to be all reals. Which makes sense because can't I plug in any number? There's no restrictions. I can square any number. I can multiply it by anything. I can add them together. There's no restrictions with adding or multiplying. Okay, restrictions only come from division or your radicals, specifically your square roots or your fourth roots, your even roots. So here we have our domain is all reals. Our range, we want to find that high point. So we can actually specifically find that by doing second trace. So we can find that maximum by pressing number 4. And we guess the left side. So I'm going to go a little bit left of my maximum just to be safe. And then I'm going to do the right side. I'm going to go a little over. Here's the right side. And then it says guess. So that's close enough. There we go. So the maximum is here. So the maximum y value is 1.25. So my range is everything is less than or equal to 1.25. Okay? Okay, so we're going to start with inverses. I did skip over the word problems for now. We'll go back to them later. Okay, I wanted you to understand the math first. So, an inverse function. What we can do is we can write, here we have our equation, f of x equals x plus 5. So just to get an idea, let's get some points. So if I have the point, if I plug in 1, I'll get 6. 1 plus 5 is 6. Plug in 2, I get 7, right? 3, 8, 4, 9. So there's 4 points, just to get an idea. The inverse function, okay, so the inverse of this is actually going to be 61728394. So notice what I did with every single point is I switched the x and the y. And that's what's happening here. The domain of f is the same as the range of the inverse. The range of the original function is the domain of the inverse. Okay? So let me show you how I got the inverse function right here. Okay, so let me just move this around. Well, whatever, for now. Just going to rearrange the whole screen. Okay, so this is how I should have had it. Let's see. So here we have basically y equals x plus 5, right? This is just a fancy way of saying y. So for the inverse, we switch x and y around. So instead of it being y, it's going to be x. Instead of it being equals x plus 5, it's going to be y plus 5. We don't change anything else in the equation, only the variable y and x. Everything else stays the same. So now, all right, this is my new equation. But we don't write equations as x equals, we write them as y equals. So move that 5 over. So we get x minus 5 equals y. This is our inverse function. It's y equals x minus 5. But we need to notate that that's the inverse function. So we're going to use f, it looks like raised to the negative 1 times parentheses x parentheses. Okay, that doesn't, it's not a negative 1 exponent. This is inverse notation. All right, this just lets me know that it's not my original function. It's a manipulation of my original. Okay, So let's see, the next part. So we're going to find the inverse of this function informally. So f of x, fancy way of saying y equals 5x. So change colors. I'm going to do the inverse now. So we get x equals 5y. Get y by itself, so y equals x over 5. So y equals, right, put it in inverse notation. There's our equation. Now we want to find the inverse, where inverse at 2. So we write it and plug it in. It'd be 2 over 5. There's the final answer. Okay, so second example, find the inverse. So let's do this again. We're going to write it as y equals 2/3 x plus 1 inverse. Change it around. X equals 2/3 y plus 1. Move the 1 over. I don't like that 3, so I'm going to multiply everything by 3. So I get 3x minus 3 equals 2y. Now I can divide by 2. 3 over 2x minus 3 over 2. So my inverse is just 3 over 2x minus 3 over 2. So let's find the inverse at y. At 5. Why did I say y? I'm tired. Story of my life. Okay, so 3 over 2 times 5 minus 3 over 2. So that's 15 over 2 minus 3 over 2. So we get 12 over 2, which is 6. And that's our final answer. All right, let's do another one. So find the inverse function informally. Okay, and then we're going to plot the graphs to show that the graph is a reflection, blah, 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 right? So let me explain what that means. So we get y equals 4x minus 2. All right, start with what we know. Finding the inverse. So we do this. And let's see, you do some work. You should get the inverse should be 1/4 x plus 1/2, or 2 over 4. All right, the next thing, don't know why I pulled that up. The next thing is I want to graph it. So we're going to clear that out. We have the original equation. Let's see. All right, just so I don't confuse you, my second one is in red, so I'll make that one my original equation. So 4x minus 2, and then the blue one I'll do in my blue writing. So just because decimals are easier and exact here, I'm going to write it this way. So now we can graph it. So we have our inverse line there, and the red line is our original. So our original and our inverse. Okay. There's a relationship between that, and that's a reflection across this line, the y equals x. So let's graph what y equals x is. All right, I'm going to make it green just so it's easy to see. So this is cutting it exactly in half, right? Tilt your head, and there you go. You've got it so it's symmetrical. Okay, it's this nice little reflection across. So why would that happen? Well, what did we do? To do the inverse, we changed x and y around. So it would make sense that we would change across this line, right? Because we flipped our y's and our x's. Okay, so that's what that's trying to show you. Okay. So here, I would do a little sketch. So let me do that real quick. Okay, so this was my quick sketch of the original function, the inverse, and it crossing over the y equals x. Again, it's not perfect, but that's how I can show what it looks like. Okay, so this is everything you should have learned from this, minus the word problems. We will get back to that. All right, but now at least you know what a function is and what an inverse is.